Hello, this is topic 3.2 rates. Today we're going to write rates as fractions, and we're going to then find unit rates. And from unit rates we're going to calculate the best buy based on a cost per unit. So first up, let's talk about what a unit rate or price means. What this means is the price or amount for one. So it's a cost or rate per unit of measure. So if you're buying 3 shirts for $25, to calculate the unit rate, we're going to take that $25 and we're going to divide it by 3. And that will give us the price of an individual shirt, which is $8.33. So today's lesson is all about unit rates and then calculating best prices. Rates and ratios are very, very similar, and in fact we can write them the same way. So as we learned with ratios, we have 3 ways to write, and if we look at rates, the difference is about the units. So ratios compare 2 quantities that have the same units. For example, 12 people to 5 people, so we can write that as 12 to 5 or 12:5 or 12 over 5. Those are the 3 ways we can express ratios. With rates, we have different units. We still express in the same way, but we have to include the units when we do so. So 500 kilometers in 5 hours, we would say 500 kilometers to 5 hours, or we could say 500 kilometers colon 5 hours, or 500 kilometers fraction bar 5 hours. So the difference between a ratio and rate is about the units, but the 3 ways to be able to express them, that stays the same. The great thing about rates is we use rates all the time in our everyday life. So when we compare 2 things that are measured in different units, we call that a rate, and we can see the examples here of rates that we're very comfortable with. Speed in kilometers per hour, like 60 kilometers per hour speed limit. Fuel consumption in kilometers per liter. So maybe a big truck versus a small car, they're going to have different rates of fuel consumption. Wages, how much money do you make in dollars per hour? And then when you're grocery shopping, the cost of something in dollars per kilogram or per pound, particularly things that we weigh like apples or oranges. Produce is typically where we're looking at that type of rate. When we express unit rates, what that means is we're going down to a single unit or quantity. So per hour, 1 hour, per liter, 1 liter, per hour, per kilogram. That's what we see for these 4 examples. So these would all be showing as unit rates. So for example, number 1, it's already expressed as a unit rate, 50 kilometers per hour. That's a single hour. So 50 kilometers for 1 hour or 50 kilometers to 1 hour. For numbers 2, 3, and 4, what we have to do there is do some division to get the unit rate. So 80 kilometers in 2 hours, so we're going to take 80 divided by 2, and that will give us 40 kilometers in 1 hour. For 90 cents for 6 grams, we're going to take 90 cents for 6 grams and then divide 90 divided by 6, which gives us 15 cents for 1 gram. And then $12 per 3 people, $12 divided by 3 is going to give us $4 per person. So the unit rate is where we say that per, right? 40 kilometers per hour, 15 cents per gram, $4 per person. We keep the units, they don't cancel. So even though we divide the number, We are definitely going to keep dollars and people or cents and grams. We keep those units. And then we have a simplified example. It's a unit rate whenever we have the second term equal to 1. So what we've got showing in our denominator, that goes down to 1. And then the numerator, of course, can be any number at all. So 3.2a do together, we have Jada taking 3 hours to deliver 189 newspapers on a route. What is the rate per hour at which she delivers her papers? So we know that we're looking for the unit rate because it's for 1 hour, and we know that we've got different units, hours and newspapers. So we're going to take those newspapers, and I'm just going to write NP for newspaper over 3 hours, and we're going to do the division there. And when we take 189 and we divide by 3, we're going to end up getting 63 newspapers per hour. Remember, we can express this as 63 newspapers over 1 hour to 1 hour, or we can write it 63 newspapers to 1 hour, or we can write it with the word 63 newspapers to 1 hour. So we're expressing it the same way as ratios, but it's a unit rate. So we're going to go ahead on exercise 3.2a, just a few questions more. So we're going to be expressing each of these rates as ratios. So what they mean by that is you're writing them in that same format that we've seen when we started with ratios. So we're writing it in simplest form with the second term equal to 1. So we're writing unit rates here, and we are being sure to keep our units. So we have 95 cents for a dozen eggs, which is 12. So we're going to express this as a unit rate by dividing 95 divided by 12, and that will give us 8 cents to 1 egg. Or you can write this as 8 cents colon 1 egg, or you can write it as 8 cents to 1 egg. So those would be the 3 ways you could write this unit rate expressed like a ratio. Remember, we must show the units. Number 2, we have 1,000 kilometers in 4 hours. So we're going to then divide 1,000 divided by 4, which is 250 kilometers per hour. And again, we could write this as 250 kilometers with a colon, 1 hour, or we can write it with the word 2. 250 kilometers to 1 hour. The number 3, notice that we already are down to 1. We're down to 1 minute. So this is 3,000 revolutions per minute. So we can just express this. We don't have to do any divisions for this question. Now, where unit rates really shine is when we're actually shopping and trying to find the best buy, because I think we all like to find the cheapest price possible. And here we've got 4 different kinds of juice boxes. They're all apple juice, but sometimes in the store it gets confusing which one's the cheaper one. This is coming from Superstore. Superstore, on their website at least, makes it really easy for you to compare unit rates. So they're taking the price and then they're dividing. Now they're not getting us down to a single milliliter. They're getting us to 100 milliliters, but notice that we can easily then compare each of these prices per 100 milliliters. So we can see the best buy through calculations of unit rates, and that's what we're going to do next. So when we're buying packages, things with different quantities, so maybe you're buying comparing a big bag of chips to a small bag of chips, and you really want to know what the best deal is, that's where finding the unit price comes in handy. So the key idea for this lesson is to calculate the unit price. We always put the money amount on top. We put the money amount in the numerator and the unit amount in the denominator. Then we divide. Okay, so let's look at this example. Find the unit price for each quantity and tell which the better buy is. 10 grapefruit for $4.25 or 12 grapefruit for $4.80. Now you have a choice here. These are both in dollars, so you can leave the decimal in, or you can take the decimal out, making it into cents. The book recommends getting rid of the decimal just to make it easy to compare, or easier. For me personally, I like to keep the decimal in because we're going to be getting comfortable with comparing decimals anyways. So I'm going to put the $4.25 up top for the 10 grapefruit, and I'll just use G for grapefruit, or maybe GR. And then for the next one, the $4.80, I'm going to be dividing by 12 grapefruit. So the book shows this example slightly differently, but really we're finding the unit rate, and I'm doing it with dollars and the book has converted it to cents. We're going to be able to compare them equally well. So $4.25 divided by 10 gives a decimal of 0.425. So that really means one grapefruit, to show that, one grapefruit is actually just about 43 cents. For the $4.80 one, we're going to divide by 12, giving us a decimal of 0.4 for one grapefruit. Now, if we're having trouble comparing these decimals, we can make them the same in terms of their length by adding 2 zeros in, and we can compare that. We see 0.4, it looks like 400 really, it's 40 cents, compared to 425, which is going to round up to 43 cents. So we can definitely see that the 12 grapefruits is our best buy. So we're going to say the 12 grapefruits is the better buy. So that's how we will answer the question. We don't have to answer showing the decimals in our sentence answer. We can just state which one is best. For this next example, we're finding the unit price for each quantity and telling which is the better buy. So we have a 360 milliliter can of beans for 90 cents or a 500 milliliter can for $1.10. Now this time the money amounts are shown in different units. One is in cents, one is in dollars with a decimal. So this time we will have to make a change. So I'm going to keep the cents for this example. So 90 cents is the cost of the 360 milliliter can. And so I'm going to take $1.10 and I'm just going to get rid of that decimal and make it into 110 cents. Same quantity, of course, just taking that decimal out. So you want to be consistent. You could also make the 90 cents into 0.90. That would work too. So now we go ahead and divide. 90 divided by 360 gives a 0.25. Okay. So that's less than a cent, a quarter of a cent per milliliter. And then 110 divided by 500 gives us 0.22. So we can easily compare these decimals, that we can see the 500 ml can is the cheaper price. That is our best buy. It's the lower decimal. So the 500 milliliter can is the best buy. 3.2b do together. We're going to solve for the best buy, and if we need to, we're going to round our answers to the hundredths place, hundredth of a cent, which is 2 decimal places. Number 1, the local store charges $6.50 for 5 pounds of grass seed, or you can get 25 pounds for $27.75. Which is the best buy? Okay, so let's set it up. We remember that unit rate means that we're going to have money on the top and the unit on the bottom, the 5 pounds. And then we're going to compare that with $27.75 for the 25 pounds, and we'll see which one is cheaper. So we're going to go ahead and we're going to divide now. 6.5 divided by 5 gives us 1.3, or what we could say is $1.30 per pound. So 1.3 or $1.30 per pound. And then the next one, we're taking 27.75 divided by 25. So we're going to get 1.11. So that's $1.11 per pound. So we can see here right away that 1.11 is smaller than 1.30, right? So we know that this one is our best buy. So the 25 pounds is the best buy. For number 2, a store has vitamins on sale. Brand Y is $2.35 for 50 tablets. Brand Z is $10.50 for 200 tablets. But they both have a coupon. Brand Y's coupon is 50 cents and brand Z's is $1.50. Which brand is the best buy? Okay, well, we've got to apply the coupon to the regular price first. So for brand Y, we're going to take $2.35 and we'll subtract off the 50 cents. And so that's going to give us $1.85 for the 50 tablets. So I'm just going to use T for tablets. For brand Z, we're taking the $10.50 minusing $1.50, which gives us $9 for the 200 tablets. So now we can go ahead and divide 1.85 divided by 50 gives us a decimal of 0.037. So that's about, if we round up, it's about 4 cents for each tablet. And then for brand Z, we take $9 divided by 200, and that's giving us a decimal of 0.045. So that's almost 5 cents per tablet. So brand Y is our best buy. So I will just say that in a short sentence. Brand Y is the best buy.